Hello. I think you should be able to hear me now. Um, you should see the desktop and you should be able to hear me. Does everything seem okay?
Yeah.
Yeah, everything seems
Yeah.
fine.
Okay, great. Thanks. Okay. Okay. So today we're going to finish talking about methods. And what we need to talk about is one more topic. It point out here something called method return values. Okay. So we're going to talk more about string methods and a little bit about turtle methods, and also talk about writing our own methods. And we're going to emphasize return values in all of these things. Okay. So let's start with some examples of string methods. So I put up. Let's see. Let me show you. I haven't created a link to. I have something up on the website, but I haven't created a link to it yet. Okay. So for class, there's a bunch of tables of things. So each one of these is a little table, and then we want to look at one down here called some useful methods of string objects. And it's not loading. Let me download it. Okay, here's a table. This shows you the methods you can call on a string object. Now, what we did the other day, we did these examples here. Ah, okay, this is some code we did yesterday on Tuesday. Okay, so we created a string, and then we created a now remember this created a reference variable that points at an object. So remember these would be like when we work with turtles, this is be the name of the object, the name of the turtle, and this would be represent the turtle itself. In this case, this is the name of a string, and this is the string itself. Okay, this creates another name for that string. Okay, and then see, this is where we call a method on the string. And if we look at, remember, if we watch this happen, okay, there's the string thing, the string, what we call the string object, and there's the name for it. Okay, we use the name as a way of referring to the object so we could tell the object to do things. Okay, then we created another name for it. We didn't create another string. Notice the word string here twice. There's not two strings, there's one string and two names for that string. And this is going to be something we have to keep worrying about over and over again. Okay, there's string one is one name, string two is another name. Okay. Now this creates a second string object because what it does is it says to this string, convert yourself to uppercase. But you don't end up with capital H, capital E, capital L, L, O here. When you send this guy the message that he should make himself uppercase, he creates a new string object. So then this is a name for that string object. Okay. This thing here is the return value. See, you called this method and got back an answer. The answer is what we call the return value from calling a method. So we want to talk a lot about this idea. It's really important that you call a method and it gives you back an answer. Okay. When you call a method, sometimes it changes itself. Sometimes when you call a method, this thing would change. Sometimes when you call a method, you get back an answer. Okay. And those are different ideas in computer programming. The difference between calling a method and getting back an answer and calling a method and then it changes something. Okay. Now, strings actually never change themselves. So with turtles, we can see that difference more. With strings, whenever you call a method on a string, the string actually, this is one of the things about Java, strings never change themselves. but turtles can change themselves. When they move, they change themselves. So for example, if we go compare this to a turtle example. Okay, now let me see. To do turtle examples online, there's a link to a page where we could do turtle examples. Let me see if I remember where it was. Oh, okay. Here's a page where you can write your own turtle code. See, they just give you a blank place, but this is on the website where this is part of the textbook, so you can write turtle code here. So I could write a code here that says world W equals new world. I'll make a 300 by 300 world. Okay, if I run this, oh, I have to tell the world to show itself. Okay, I forgot that in Dr. Java you don't have to tell the world to show itself, but here you have to say w.show. If I remember right, w.show is what shows it. There, see, there's the world. Now let me put a turtle in it. Call it T1 equals new turtle. Okay, now we don't see a picture of like this, but what I'm doing is I'm creating a T1 variable referring to a turtle object. Okay, but we'll see the turtle object appear in his world, but we won't see the variable T1 like we see here in the Java visualizer. But we're still creating a, oh, what did I do wrong? Oh, I forgot to tell the turtle what world he belongs in. Okay, so there I see the world with the turtle in it. Okay, now I can start calling methods on the turtle. Okay, T1 dot forward. Now there's no return value here. See, I don't get an answer. I don't put anything here. I don't get an answer back from the turtle. See, here, when I said S1 dot to uppercase, I called that method on the string, and I have to save the answer in another string variable because it gives me back a return value. So I have to save it somewhere. With turtle, the string doesn't change itself. It makes a copy of itself and gives me back the copy as an answer. Turtles change themselves. This is going to change where the turtle's location. So the turtle, if we drew a picture of what's inside the turtle is remembering where he is. And then this is telling him to change where he is. So then I have to run this. Okay. So I called the method on the turtle. The method made the turtle change himself. There's no return value. Okay. So we have two kinds of methods that change an object and methods that return an answer to a question or just give you a result of an operation. Here, do something. The something we want to do is this could have been the change. This could have been designed by Java to make this letters turn themselves uppercase. But Java decided not to do it that way with strings. They said when you call to uppercase, you get back an answer, and the answer is where the uppercase letters are. Okay. Now here's another one. I'm going to take this name here and reuse it, and I'm going to make it point at the substring of S3, which is capital HELLO, the substring from the first starting at letter 1 up through letter 4. Okay. Now remember, capital H is letter 0. The capital E is letter 1, 2, 3, 4. The capital O is letter 4. This is starting at that letter 1 up to, but not including the letter 4. So that would be starting at E, LL, not including O. So it'd be the string ELL. Okay, now this guy's not going to chop himself down. This is not going to chop itself down. It's going to make a copy and chop off the copy. Okay, so it made a copy of itself and chopped the copy, and the copy is the return value. Then I recycled that name, and made it a name for the return value. So I reused that name and said it should be a name for the return value of that method. Okay. And then over here, there's things you can do to a turtle that would give you a return value. Okay. So I can ask a turtle where it is. So I can say int x equal t1 dot. Now I don't remember the command. There's a way to ask a turtle where it is. So here's how we would do that. It's in, I'm going to open another tab to this chapter. Okay. Here's where this calling methods with parameters, there's a little table in here of turtle methods. Okay. Here's a little table of turtle methods. Okay. Um, See, the turtle remembers his x position. He remembers his y position. He remembers his width and his height. Okay. And here are, this is not complete list of methods you can call, you can do a turtle. Oh, they don't show you the name, how you get his, um, they don't tell, I can't, let's see. Maybe they did an example. No, let's see. Oh, here it is. See, here they asked the turtle, where are you? Get your X position. Now, so they capitalize the X and they capitalize P and they abbreviated position. Okay, so so here's the information. Here's the little table. The table's not very complete, unfortunately. There's not very so the turtle remembers his X position and his Y position, and then there should be in this list a method here that says get your X position. Now that doesn't change the turtle, but it gives you back an answer. So let's go over here and we'll say T1 dot get your X position. Okay. Okay. And then I'll print so I can see what the answer is. I'll system dot out dot print line X. So I can see what the answer is. Because we don't see over here, we see the variables. Okay. Over here, we don't see the variables. We see the output of the, we see what the turtle does, and we can print out things. So if I run this, where did the, I should have my window that shows me this thing. So that window's supposed to be there. Did I, huh? It's not showing me the output window. I'm not sure why this one's not showing me the output window. That's too bad, because otherwise, how do we know what we wanted? We asked the turtle for an answer. Okay, let me switch to Dr. Java. Okay, so let me just stop using this one and go to Dr. Java. Okay. I'm not sure. I thought this one would also show us the output window where system.out.println is going. So let's switch to Dr. Java. Technology is fun to use. There's you expect things to work a certain way and they don't always. And you have to become familiar with every little piece of technology you use. Like, okay, now here Dr. Java started up in that weird case where I just got the little spinning arrow and it won't go away. So I need to quit Dr. Java now and start it up again. About every 1 out of 3 times I start Dr. Java, it starts like that. Okay, see, now this time is fine. Okay, there's no problem with Dr. Java. So there's our program, okay? And I'll compile it. Needs to save it. I'll save it on my desktop. Okay. Now in Dr. Java, I don't need that line there. So I need it on their website, but I don't need it in Dr. Java. Okay. Compile and run it. Okay. Then see, he's now at location 150. Okay. His X position is now at 150. And if I want, I can write that a little bit clear. I can say X position equals quote plus. Okay. So I can compile, run it again. See, his X position is 150. Okay. What's his Y position? Okay. So and I would need to ask him what his Y position is. So int Y is get Y position, and then print out the Y position is, okay, now this is the return value. I need a variable to hold the return value in. So I asked the turtle by calling this method, what is your Y position? And I get a return value. I get an answer, and I save the answer in a variable. If I don't save the answer, I don't have to actually save the answer in a variable. I could just do that, but then I wouldn't know what the answer was. Java won't complain about me doing that, but I won't know what the answer is. So if I'm asking what is the Y position, it certainly makes sense to save the answer in a variable. Then if I compile and run it, see, I get the X position 150, Y position is 50. Okay, so that's where he is right now. Okay, and then if I wanted to, I could ask him that question at the beginning. So let's do this. Take this, and before we tell the turtle to move, let's ask the turtle that question. Then we tell the turtle to move. Now, since I've already created X and Y here, I should not create them again. I'll reuse them. Okay, so first I say this creates the X variable, just like this creates the turtle variable. This creates the turtle variable, that creates the turtle. They're different. Remember in the picture we see over here, we don't see that picture, but we see this picture, how that's the variable, that's the string. The variable points at the string. Okay, so you could have, and you could, if you go backwards here, you can have more than one variable pointing at the same string. Same thing's true of turtles. I could have more than one name for that same turtle if I wanted to. Okay, then so that creates the turtle name, that creates the actual turtle. Then I ask the turtle right away, where are you? Then tell the turtle to move, then ask it again, where are you? When I first ask it, where are you, I have to create the variable that holds the answer, but I already have that variable now, so I don't have to create it again. And I have to create the variable that holds that answer, and I have it now, so I don't have to create it again. I can just, now I'm replacing that answer with a different answer and then printing it. Okay. So he starts off when he's created, he was at location 150, 150. So the center of the screen is not the origin. Turns out that the turtle thing is kind of funny. The center of the screen actually isn't, from the turtle's point of view, 0, 0. In this case, I think 0, 0 is over here in the lower left-hand corner. And this is a 300 wide. See, this is a 300 wide by 300 wide screen. So the way they're doing it is 0, 0 is down here, 300, 300 is up here. So the center of the screen is 150 over, 150 up, which is kind of weird. You'd think that they would put 0, 0 in the center. That means if you change the size, like watch, if I change the size of the screen, now he's going to start off at 200, 200. Instead of starting off at 150, 150, he always starts at the center of the screen, but his location depends on the size of the screen. So now I'm going to get a bigger world. I have a slightly bigger world. See, he started at 200, 200, because the world is 400 across by 400 up. So the center is 200 over, 200 up. So he started at 200, 200. I think that's kind of a dumb way for them to have done this. They should have made the center of the screen 0, 0, made these negative numbers, these positive numbers. That way the turtle always started in the same place. But the way they did it, every time you change the size of the screen, the turtle happens to start in a different place because he starts in the center of the screen. 0, 0 is down here, and there are no negative coordinates. If you use a negative coordinate, you're down below here or to the left of the screen. So they did this probably so that you'd only be using positive coordinates by putting the lower left-hand corner at 0, 0. Okay, so they did it kind of, I think that's kind of an odd way to do it, but that's the way they do it. So the turtle starts at the center of a screen, and the center of the screen is half the width and half the height. Okay, so these methods give us the turtle. Now, this method changed the turtle. The turtle changed what's inside of him. So the turtle had 200, 200 stored inside of him. You move forward, that changes what's inside the turtle, and then this thing tells you what's inside the turtle. With strings, these methods don't change what's inside the string. What's inside the string, what's inside the object is the letters HELLO, and when you call the method on it, call this two uppercase method, it would have been reasonable for Java to say, okay, we're going to change what's inside the string. But for some reason, they chose not to do it that way. And it's actually not a bad, in the case of strings, there's a good reason. Later on, you'll learn why they made this choice, why they made the string not change its inside and made the string instead make a copy and put the new data in the copy. Why they made that change is a good idea. But it'll be a while before you can learn why that's a good idea. For now, you just have to remember that two uppercase works differently than, for example, the turtles did. It didn't change what's inside that turtle, that string. It didn't change what's inside that string. It made a copy of the string, and then this thing gets the new answer. Okay. When you're changing what's inside the object, you don't need to there's no answer. See, there's no answer here because the answer is inside the object. You're changing what's inside the object, so the answer is there inside the object. So you don't have a return value here. There's no return value to this thing. On your hand, when you want to report an answer, you need the reporting the answer is the return value. Okay. Now, a string can also give you answers other ways. So a string can give you an answer without changing itself. So here's an example of a string int length equal s3 dot length. This is telling the string to measure its length. That doesn't change what's in the string. This would have changed what's in the string, but it made the string make a copy of itself. This just returns a number that is how long the string is. Okay, so that's the return value. And this string just goes and counts how many letters are in himself and reports that. Kind of like the turtle telling you where he is. The turtle just looks inside of himself and says, this is what I have recorded inside of me as what my location is. The turtle looks inside of himself and just says, I'm reporting to you what I have stored in me as my location. This thing causes the turtle to change his location. Now, this thing just says to S3, look inside of yourself and count how many letters there are and report that. Okay. Now, here, see, we create this new variable, len, L-E-N for length, and we asked S3, which was capital H-E-L-L-O, how long are you? And got back 5. So that's the length of capital H-E-L-L-O. Okay. The original string, the original H-E-L-L-O went away because we recycled that name. See, that name was pointing at that string, and then for some reason, I just decided I want to make that name another name for that string. So I said S1 equals S2. That copied this arrow into here. That pointed this arrow at this one. That left this string with no arrow pointing to him. See, after line 9, this arrow would move down to here. This would have no arrow pointing at it. Remember we mentioned that's called a garbage object. An object with no arrow to it we call a garbage object. Garbage objects are usually not shown. They're actually deleted. They disappear when Java notices that an object is garbage, and it gets what's called garbage collected. Okay, so Java collects the garbage objects and deletes them. So when I do forward, that lowercase hello is gone. It got garbage collected because it lost its arrow to it. Okay. If I created another arrow before that, just before that, I could have said string S4, create another arrow and make it point to S1. Okay. Now I'm going to give this guy a second arrow, and then I'm going to take away his first arrow, but he'll still have that arrow so that it won't go away. So I can visualize this. Okay. Now I'm going to give him a second arrow, a second name. Now I'm going to take away this name and point it at capital HELLO, but I won't lose the original string name. Okay, see that the arrow just moves. This line takes the arrow that's in S3, that arrow, copies it into S1. So the S3 arrow gets copied into S1, but that moves S1 to point over to there. Okay, but then that string still has the S4 arrow, so that string doesn't go away. One of its arrows just moves over here. Okay. As programmers, we keep track of these arrows. Notice that I've got 3 names and 4 arrows. 1, 2, 3, 4 string names, but not 4 strings. 1, 2, 3, 4 string names. So that's 4 arrows, but not 4 string objects. I've got 1 string object here that I created. This guy created another string object as its return value. So that gives me 2 string objects, this one and this one. And this creates another string object as its return value. So I've got 3 string objects, one that I created with these quotes, and then one that was the return value of that method, and another one that was the return value of that method. Okay. Now, here's another thing I could do. Suppose over here, I change that line there. This one's a little bit tricky to read. This is saying to the S1 string, make a copy of yourself that's all uppercase, but then it's making S1 a name for the copy. So S1 stops pointing at what it was originally pointing at, and S1 now starts pointing at the copy. Now, S1 won't go away because there was a second arrow for it, but this is kind of funny. This is saying to S1, make a copy of yourself, and then point S1 at the copy itself. Oh, I don't, and since S1 already, I need to delete since I'm reusing the name, I don't declare it again. See, I'm reusing that name. Earlier, I was creating a new name. Here, I'm recycling that name, so that variable already exists, so I don't redeclare it. Now what do I do? Oh, but now I don't have S3 anymore, so let me do S2 here. Okay, so now I'm going to do the same thing. I'm going to say to S2, create a substring of yourself, but then make S2 a name for that substring. Okay, so I will lose a string there. So let's watch what happens. Oh, now let's just not do that one yet. Okay, so let's look at what these do. So create a string, create another name for that string, tell the string using name S1 to create a copy of itself, but then reuse S1 as the name for the copy. Okay, then say to S2, make a copy of yourself that's a substring of yourself, then use S2 as the name for the copy. Okay. Okay. So there's the string HELLO. There's a second name for it. Okay. Now this guy is going to become a name for capital Hello, okay? And then S2 points to this one and says, now make a substring of yourself, but then use the name for the substring. So we're going to lose this string here. This one's going to disappear on us. We'll lose lowercase hello and replace it with ELL. You know, they kind of switched order. See, S1 points to capital HELLO, and it still does. It just kind of reversed the order of them. S1, HELLO. But S2 was pointing at lowercase HELLO. And we said S2, create a copy of yourself that has only the letters ELL, but then make S2 a name for the copy. So S2 is pointing at this one. It's going to chop it off and make a copy with that. But then this arrow is going to point at the copy. So it's no longer pointing at HELLO. So we lose HELLO. It makes it look as if this thing changed itself, but it didn't change itself. It made a copy, then we lost the original. This line looks like you're making S2 change itself, but you're really doing something more subtle. You're saying to S2, make a copy of yourself with those letters in it, then make the variable name a name for the copy, which means you lose the original. So there's still two strings, the original and the copy, but we lose an arrow to the original, so it seems to disappear. So it looks like this one chopped itself off to this one, but it didn't. This one made a copy of himself, which was a chopped off version of himself, then made this thing point at the copy, but then this one didn't have an arrow to it, so it got deleted. Okay, so it looks like it got changed, but it really got copied and deleted. And as we go along, you'll see that the subtle difference between these little, the difference between the fact that this is not changing S2, it's actually making a copy of S2 will matter as we go along. We have to really understand the difference between return values and things that make changes. Strings never change themselves. They always make copies. Turtles change themselves. Turtles update themselves. Okay. Some objects are like turtles. They update themselves. So when you tell a turtle to update itself, you don't have to, there's no new turtle. You don't have to get a return value. The turtle just makes the change in itself. Then there's objects that are like strings. They never change themselves. They always make a copy of themselves. So you have to get the answer here. You have to record the answer. And remember, if you don't record the answer, we did that. If you just do that, okay? Let me comment that out. Okay, that, surprisingly enough, doesn't do anything because that creates a string and points S1 at it. What this does is it says to that string, make a copy of yourself that's all uppercase, and then it does not give a name to the copy, so the copy just gets created and disappears. What happens is actually, oh, I need to get rid of that line too. Create the string, give it that name, tell that string to make a copy of itself that's all uppercase, but I never give a name to the copy. So it's as if nothing happened. It did make the copy, but the copy got garbage collected. So Java actually went through the trouble of creating an object and then deleting the object right away. Okay, so it created the object and deleted the object. And I can actually prove to you that it created the object. I can do the following. Int x equals s1.2 uppercase dot length. Now, what does that do? Takes this string, tells it to make a copy of itself that's all uppercase. So there is the copy that's all uppercase that we never see because it's never given a name. But before it's garbage collected, we ask, how long are you? Now that question is being asked of the copy because that's being done on this thing. So that copy is sitting in memory briefly, and it's sitting there long enough to be asked, how long are you? And then the answer goes in here. Now the length is the same length as this one, but we'll get an answer in here, even though we never see the copy. So if I go here, see X is 5, but the 5 was the length of the string we never saw. Okay. Here's another example of that. Instead of saying the length of this guy, I'll ask for the substring between, say, 3 and 4. Okay, so now I'll make this a string because I'm asking for a substring. Okay, now that's letter 0. That's letter 0, 1, 2, 3. The second, actually, let me make this from 2 to 4. So that would be the 2 L's. Okay, so that'd be string 0, 1, 2, 3, not including 4. So that'd be from letter 2 up to not including letter 4. So that'd be the 2 L's. So tell S1 to make himself all uppercase. So that's capital H, capital E, capital L, capital L, capital O. But then that string is said, give us your substring from 2 to 4. That makes a third string. That third string is just capital L, and that's what we remember. So we'll see the third string. We won't see that middle string, but it was there because it'll be used to create the third string. So this is kind of a weird thing to write, but it does what we want it to do. Okay. There's S1. There's the string HELLO. See, there's the string LL. Now, that method created a return value that held capital H, capital E, capital L, capital L, capital O. That return value, we don't see it, but it's used to call this method. This method's called on that return value. And it says to capital H, capital L, capital E, L, capital L, capital O, make a copy of yourself that holds only the capital L, capital L. And that's the return value that we're remembering here. Okay, so what's remembered here is the return value from that. So this can be tricky to read. Yeah, it captured 2 letters out of this string in all capitals. Okay, I could also do something a little bit different. I'm going to do this. Okay. Now, S1 hasn't been changed at all yet. Remember, strings never change themselves. So I'm going to start back with S1, and I'm going to reverse the order now. I'm going to do substring 2, 4, then 2 uppercase. Okay. I'm going to reverse the order of those. And it's going to end up doing the same thing, but in a different way. Now I'm saying to S1, chop yourself off in a copy. Make a copy of yourself and chop off the copy. So make a copy of yourself and chop off the copy from the second letter to the third letter. So that gives me lowercase l, lowercase l. But then that string is told to uppercase itself. So I'll get capital L, capital L. So I get X and Y will be the same thing. I get the same answer, capital L, but if somebody asks me what does this line do, and if somebody asks me what does this line do, they both give me capital L, but they don't do it the same way. So if somebody asks me what does this line do in detail, I would tell them in detail it takes the original string and it makes a copy of itself that's the string capital H, capital E, capital L, capital L, capital O. Then that string of all capitals is told to chop itself off in a copy. Whereas this one says to the string that's HELLO in lowercase, make a copy of yourself that's just the letters between 2 and 3. So that would be lowercase l, then this tells the lowercase l string to make a copy of itself that's all uppercase. We don't see this string, and we don't see that string because we never gave them a name. We gave a name to the return value over here. Okay, so there's subtleties to reading these things, and you really might think that the only thing I care about is what the answer here is. Okay, but when you're learning to program, one of the things we'll ask you, like on a test or in a question, is to explain all the steps in a line of code like that, because programmers have to understand all the steps of what's going on. It's true here that the only thing I really care about is what the final answer is. But as a programmer, I have to understand how that answer got there, because I have to understand how this code works. Sometimes things don't work the way you want them to. Sometimes you have to make a change. So you have to understand how this is working. Okay, so it isn't enough to know just what the answer is. You have to know how it got to that answer in a two-step process. Create a string that we don't see, then call a method on that string, on that return value. On the return value, call that method. On that return value, call that method. Altogether, this does the same thing as this. Okay, but I have to, I still have to know what it is they did in detail. Okay, so strings never change what's inside themselves. They always return a copy. Turtles, on the other hand, have lots of ways of changing what's inside themselves. So we didn't make the turtle turn in any way. So down here, we can say to our turtle, T1 dot turn 45 degrees. Okay. Oops. Oh, I keep misspelling turn. Okay. Run it. Okay, so we see he went up and he turned 45 degrees. One of the things the turtle, now that made the turtle change something inside of himself. He changed his angle, his heading. Now, let's see if they have a method. There should be a method that lets us ask a turtle, what is your heading? Now here they ask the turtle, you can ask a turtle how wide it is and how high it is. You can ask its X and Y position. I don't think they have an example. Yeah, they don't show what they do, and it wasn't in here. You can tell it to turn. So I'm not sure what method they used for getting the heading. Let's just try. I'm not sure. You can just guess. Heading is stored as doubles in degrees. I'm just going to guess that they called it its heading. Now, if I compile this, it compiled. So that was the right guess. Get heading. Okay. So go ahead and print it out. Okay. Heading equal E. Okay. That's the heading in degrees. Okay. Okay. See, its heading is 45. Okay. So yeah, if I want to know now what is, let's see what's asked what his heading was at the beginning. So he started out. Ask his heading, tell him to turn, and then ask for the heading again. So it should start out 0. So for in their way of doing things, angle 0 is pointing north. You remember in trigonometry class, angle 0 is pointing east. Okay, in a trigonometry or a calculus class, the x-axis is angle 0. Positive angles go in the counterclockwise direction. Here, that's the y-axis is the 0 axis, and positive angles go clockwise. So they chose to do things differently than the way it's done in trigonometry. And, that's their choice. They designed it that way. It's kind of quirky. You would think that they would make things easier for people and not do it differently than it's done in trigonometry. X-axis is 0. Positive 45 degrees would be counterclockwise. Here, x-axis is the y-axis. The 0 axis is the y-axis for angles, and 45 degrees is clockwise 45. Okay, so if I compile this and run it, I'll see that he started off at angle 0 and then changed to angle 45. Okay, and what's interesting is if I do this again, well, what happens if I just say turn right? Okay, without an, that turns him for 90 degrees. So his angle now will be 90 degrees plus 45 because he started at 45. Well, he started at 0, then he went to 45. Now we say turn right. Turn right always turns you 90 degrees from what your heading is. So this will end up being 90 plus 45 is 135. Okay, so see, we added 90 to what he was. So when he turned right, he added another 90. So turn right always adds 90 to whatever the current heading is. Okay, so calling turn right can do different. It always adds 49 to whatever your current heading is. Okay, if you just start off at the beginning, turn right makes you face east, and turn right again would make you face south, then turn right again would make you face west. But if you at pointing at some odd angle, turn right just adds 90 degrees to your odd angle. Okay, all right. Notice that these methods, no return value. No return value. What it does is it changes the data inside the turtle. This asks for the data inside the turtle, so that gives us the return value. So we have to ask for the information from what's inside the turtle. So this method changes what's inside the turtle. This method asks the turtle to tell us what is the data inside of you. Okay, we can't draw, like over here in the Java visualizer, we see inside, we can see inside of our string that, but the string never changes what's inside of himself. So we can never see the string change one of those letters, because every time a string would change a letter, it would actually make a copy of itself. So you can't see a string change what's inside of him. And we can't draw pictures of what's inside the turtles either. We can only run the turtle code and ask the turtle questions like, tell me what's inside, what your heading is. Tell me what your heading is, and save those as answers and then print them out. So we find out what's inside of a turtle. Well, if you look at this picture, you know what's inside the turtle. The turtle's pointed that way, so that tells you what his heading is. Okay. But if you want to actually ask the turtle, if you want to see the numbers, you have to ask the turtle. You have to ask the turtle what's your piece of data, what's your heading, what's your x position, what's your y position. You have to save it, the return value, in a variable, and then print out the variable so you can see the number here. Okay. So you could create a little list of all the information in a turtle. So for example, you could combine these here like this. I can print out all the information about a turtle. So here's something that'll print out all the information about a turtle, but then I have to ask for the information first. So we move this one to here, and okay, so ask the turtle his position, his x position, y position, heading, and then print it all out. then move him forward, but then ask it again. Ask for his X position, ask his Y position, ask his heading, and then print out all that information. Okay, so I create the turtle, ask it, where are you and where are you heading? Print it out. Tell him to do something to himself. Ask him again, where are you? Where are you heading? Print it all out. And then I can keep doing this. Then here would be the way to ask him something. See, I would ask him, where are you? Where are you heading? Okay, now I'll tell him to turn, and then I'll ask him all those questions again. It's kind of tedious to do this, but notice that this is interesting. See, I'm asking the turtle all these things about himself and printing them out. Then I make the turtle do something. Then I ask all those questions about him and ask him to print it out. Then I tell the turtle to do something. Then I ask all those questions again and print out the result. Then I ask the turtle to do something. Then notice I have to copy and paste this code. Okay. Now if I run this, I'll create a turtle, ask it all these questions and report the answer. Then I'll tell the turtle to do something, ask all those questions to get the answer. Okay. So he started out at 200, 200, heading 0. Then he was at 200, 100, heading 0. Then he's at 200, 100, heading 45. So it's kind of, there's a listing of all his changes. Now, here's how methods can be used in a language. It's tedious to have to do those 4 lines of code, those 4 lines of code, those 4 lines of code. Okay, that's kind of tedious. I shouldn't have to keep repeating those 4 lines of code. So methods, remember, are when you bundle in lines of code in something and give it a name. So what I'm going to do is I'm going to say, take these 4 lines of code and pull them out of there and put them in a method. So I'm going to go down here and say, I'm going to give those 4 lines of code a name. So there's the 4 lines of code. Okay. Now I want to give them a name. The way I give them a name is say public static void, and I'm going to give the name report. I want the turtle to report some information to me. And it's now this code needs to know what turtle I'm working with. So I'm going to say it takes input. It takes a name of a turtle. Okay. So the code takes name, and I'm calling the turtle T because it's here down here. I don't need to know it's that particular turtle. So I'll just call it T. Okay. So that says, get me a report on the turtle named T. So ask turtle T what your position is, ask turtle T what your heading is, and then print out the result. Okay. So now I've got this code here. Now up here, I can say, instead of doing all this, I can say report T1. So I tell, or then I could do that before I call, I can say report T1, tell T1 to change, then report, then tell them to change. Then here I can say, see, I don't need that code there. I can say report T1, then tell it to change, and then, okay. So now I can I can create the turtle, tell the turtle to report information about itself, then tell the turtle to change, report information about itself. This I'm telling report to work on this turtle. But so that's we call the parameter to the method. Then this becomes the name for him. See, when I call this method with T1, I'm saying report on T1. Well, reports on whatever turtle you told it to, but down here it's called T. Okay, this is like in math when you have, if I have a formula, a function that takes in x, and I say that the function should take the number x, multiply it with itself, and add 3 times the number x. Okay. Then down here I say, oh, I have a number y, which is 4, and I want f of y. Now remember what that means is take y, which is really 4, put it up here. So now x is 4. Okay, so y is the number 4. I'm using the name y for the number 4, but it's the number 4. Like, so if I another way to think about it, if I just say f of 3, you know to put the number 3 into here. If I use the letter y to represent 4 and say f of y, you're still just plugging 4 into here. Okay, that's what we're doing over here. This is the formula that takes in a variable, and it says do all this work with that variable. Then this says apply the formula with this actual turtle. Okay, okay. So that's this line here is like over here when we use the formula. This down here is like up here where we defined the formula. Here we gave the formula a name. We said the formula is called f. We call that, when you give a formula a name, that's what we mean by a function. You give a formula a name. We call that a function. So you can reuse the formula over and over again. Here, we don't call them formulas, we call them methods. That's like the formula that's given that name. See, that's what we want to do, and we want to do it over and over again, so we give it a name. Here, that's the calculation we want to make. We want to make that calculation over and over again, so we give it a name. So we can make the calculation once, then make it again a second time. Okay, same methods are same idea. There's a bunch of code that we'd like to do that would be convenient. Since instead of typing it out over and over again, I go ahead and give that bunch of code a name, but I have to tell it this is what you're working with. And then when I use that formula, I say, do it using that turtle, then do it using that turtle. So that name, whatever turtle that is, goes into here, and then it works on that. Okay. So now if I compile this, oh, I could click. Oh, I'm sorry. I have to close. I have to close when I remember I can't have two things open in Dr. Java. Dr. Java, I want to compile this one, but Dr. Java is actually trying to compile this one. So I'm going to go ahead and save that as a notes. But then I have to close it because it's not real Java. Okay, now I can compile the code I wanted to. Okay, and then run it. Okay, see, I got all my reports. Now I have much easier to read. Create a turtle, let it report where it is. Tell the turtle to move, let it report where it is. Let the turtle move, let it report where it is. Now, this method doesn't have a return value because, see, this void here is the thing that says this method doesn't have a return value. Okay. Now, there's nothing here that I would want to return. I want the turtle to print out what its information. So I don't have anything that I want the report method to return to me. So this doesn't return an answer, it prints an answer. Okay. Now the other methods return. Earlier we saw, like in the case of the string methods, we saw that sometimes they return values. So the next thing we should do, we run out of time today, is how do we write our own method that would return something? Like this method didn't return anything, it printed things, but it did not return an answer. So when I call that method, I don't need something over here that captures an answer because there is no answer. That's what void means here. Void means that this method doesn't return an answer. There's no answer back from it. Okay. These string methods are not void methods. These string methods are returning something. Okay? And we'll start looking at how this table here, see, there's a whole bunch of methods in string, and here it tells you what they return. So this is what we'll start with on next week, on Monday. We'll look at strings and how some of them return a true false answer. Some of them return an integer answer. Some of them return a string answer. So here's a name of a method and what kind of answer it returns. And then they give you an example of using it. So this is a little table of string methods that tells you what's the name of the method and what does it take as input if it needs an input, and what does it give you as an answer. Methods have a name, they take something in, and they sometimes give you something out. Now, they don't always take something in. Like length doesn't take in anything in, but it gives you an answer, int out. So nothing in, but an answer out. Nothing in, but an answer out. And sometimes you'd have something going into the method and something coming out of the method. Okay, so that's where we'll start on Wednesday. We'll look at these string methods and how they have both input and output, and then we'll go and write our own methods. Right here we have a method with an in, but no out, because it's a void method. Okay, so we'll quit there. We're out of time. Okay, see, is that right? No, let's see. Well, I think I had my timer set wrong. No, let's see, what time is it? We go till what time? We still have 10 minutes, right?
Yeah, there's still like 10, 15
Yeah,
minutes.
I set a little timer for myself. I must have misset the timer. Oh, I set it for 1 hour and 12 seconds, not 1 hour and I set it for 1 hour and 15 seconds, not 1 hour and 15 minutes. So I misread I set my timer for 1 hour and 15 seconds, not 1 hour and 15 minutes, which is how long class is. And so when it went off a minute ago, I thought we're done. Yeah, so we still have 10 more minutes. Okay. All right. So let's try to think of a method that would let's write a method that would do something with a turtle. Let me think. Okay, here's an example. Right now, the turtle, when I ask for where he is, gives me his location relative to what I think is kind of a funny answer, the lower left-hand corner. Okay, there's 0, 0. So this is where he is relative to there. What if I wanted to know the answer of where he is relative to the center of the picture? So I'm going to write my own method that's going to tell me where he is relative to the center of the picture. Okay, so I'm going to write my own method. And I'm going to write a method that says location X. I want his X location, but I want to know it and this is going to be of turtle, a turtle. Okay. And I want the turtle to tell me where he is relative to the center of the screen. Okay. Now that's going to give me back an answer. The answer is going to be an integer. So instead of writing void here, I write int, because now I want his location relative to the center. Okay. Now, right now, the center is, okay, so I int I'll say x1 is t dot get x position. Now that's his position relative to over here. So 0's over here. Okay. I want to know where he is relative to here. Okay. So I would subtract 150 because, well, actually the screen now is 200 by 200, the 400 by 400. So this is 200 here. So if I want to know where he is relative to this origin, I would subtract off 200 from his answer. So if he was here, I would want that to be 0. Okay. If he's over here, I would want that to be 200 because he's 200 units away from 0. If he's here, if he's over here, I'd want the answer to be negative 200. He's to the left of what I think of as 0. So I'm going to create my own location X and location Y that's relative to the center of the screen. So then I would ask him where he is, and then I want to return this answer. To return where he is minus 200. Okay. So I use something called a return statement to give a return value. Okay. Then I want to do this for the y coordinate too. So I want my own thing that says where he is relative to what I think of as the center of the screen. So I'm going to call this location y. And I'll ask him what his y coordinate is, but then I'll subtract off 200 from it. Okay. And I return that. Oh, I did the wrong one. So here's the one for y. I have one for y and one for x. Just like they have a get x position, get y position, I'll have a location x and a location y. Okay, so I'll say on this turtle, find out where he is relative to the center of the screen, and tell me where this turtle is relative to the center of the screen. Okay, now I'll go ahead and make this report using. I'll write this report using my location here. Okay, so I'll change this to okay. Notice I changed it from t dot location. Yeah, this was on this turtle. Ask it where its y coordinate is. I'm going to change that to call location y with turtle t. So now I'm getting his location relative to the center of the screen. Okay. Run. See, notice that the turtle started out at 0, 0. He started at the center. Okay. And then he moved forward. Okay. Oh, actually, I did the arithmetic wrong. When he moved forward, I think I just wrote the. Let's see, what did I do wrong there? I did the arithmetic wrong. Um, I'm not sure why these are negative numbers. Because when he moved forward, he in the turtle world, when he started off, he was at 200, 200. See, this was over 200, up 200. So he started off at 200, 200. Then he moved forward. So he should be up here at, oh, let me check. I thought zero was, maybe there's zero zeros up here in the corner. I wasn't even looking real carefully. Let's, yeah, okay. Um, let's go back here and have the turtle tell us where he is. I'm going to make a copy of this and put it here, but use the turtle's methods. See this first one, 200, 200. So he's up here at 200, 200. And then he moves forward. Ah, the Y is up here at the upper left-hand corner, not the lower left-hand corner. 0, 0 is over here. So this is positive going this way. So 100, 200, 300. I thought 0, 0 was down at the left. That's real strange. They put this in the turtle world, they put 0, 0, the origins up here, and then positive Y's go down. I thought I thought it was weird enough putting it over here and making, putting the origin down here at the lower left-hand corner. In their way of doing it, the turtle starts out 0, 0 is over here, positive X is going this way, positive Y, 100 is here, 200 is here, 300 here, and 400 here. They're making positive Y go down the left edge and positive X go across the top edge. I thought it was, they made this the first quadrant. They put 0, 0 down here and positive X went across here and positive Y went across here. That would, that would be a little bit easier to understand. Or, a lot of people, when they do turtles, they make the center of the screen 0, 0. That also is easy to understand, that this is 0, 0 and the turtle goes right, left. So the X is going across, but the Y is going down. Okay. So if I want to report his location, I want to treat this as the origin. Instead of subtracting 200 from there, I have to subtract, I have to add 200. No, add 200. Because when he's up here, he's at 0. And I want this to be they made this confusing. Okay, so when he starts off here, if this is 0, 0, we want this upper hand, from our point of view, from their point of view, this is 0, 0. From here, that would be up 100, up 200, negative 200. So this would be positive 200, negative 200. Okay, so relative to here, you've gone up 200 and left 200. So this should be, so if he starts off at what they think of as 0, 0, we would add we would add 200 to the x, because no, subtract 200 from the x and add 200 for the y. I'm having trouble thinking this morning. Anybody see anybody get the right formula? You want to, they're measuring it from here. So they're measuring how far over and down the turtle is from here. Okay, so the turtle starts out over 200, down 200, but down is positive for them. Okay, if we want to measure from here, we want to measure going, if the turtle starts over here, we would say he's up 200 and negative 200. So their x equals 0 here would be our subtract off 200. So that would be this. Okay, and their 0 here would be we should is us positive 200. So I think I got it right now. Okay. No, I still don't have it right. I have to think about it. Algebra, doing algebra in your head can be tricky. Okay. The key, we'll go back to this on Monday. The real issue is, this is how I write a method that says I'm giving you an answer. You say what type of answer here, and then you use this special new word in Java, the return word, that says give back an answer. In math, we don't write that. So if I look back at these notes, in math, you don't say return this answer. When you just say f of x equals, essentially that equal sign is the thing that says give back that answer. So when you get 3 as the input, so 3 is the input, so then you give back the answer 3 times 3 plus 3 times 3. If the input is 4, you give back the answer 4 times 4 plus 3 times 4. So this says give this as the answer. In Java, to say you want to give an answer, you say return this is the answer. Return this is the answer. So notice you don't write an equal sign there. You just write return and then a formula for what the answer is. So here I'm just doing some calculations, and then here I'm saying, and then this is the answer to give back. Okay. In math, you just do it all in one line. You just say, and you use the equal symbol to say, this is the answer to give back. This part here looks a lot like this part up here. See, the name and what the input is. So you have the name of the function and what the input is, the name and what the input is. But then instead of writing a equal sign, you put a brace and you write lines of code. And then when you're ready to give the answer, you say return, then what the formula is for the answer. So you can do some calculations and then return the answer. Okay, So that's different than that's the difference. It's the same idea. They got the idea from math. They got the idea from a function that takes in an input, then gives you back an answer. Okay. And we write it as, when you give me this input, I will give you back that answer. Okay. And then here's how you then say, now apply that formula with that input. Over here, that would be what we do up here. We call this method with that input. Okay. Or we call that method with this input. So that's saying call this guy, call that guy with that as its input. So that goes into here. So it's the same. It's real similar to, but not quite exactly like the way math does it. Okay, so we'll quit there, and we'll on Monday we'll do a few more examples of this idea of functions and methods and their return values. Okay, so if you have questions about the homework, remember there's a homework assignment out. If you have questions about the homework assignment, either come to office hours today or ask me a question by email. And we'll do more about this stuff with methods on next Tuesday. Okay. Anybody have any last second question? Do we run out of time? Any question? Okay. So let me go ahead and stop and have a nice weekend and see you again on Tuesday. Bye.